Hello students, myself Jayant Popat. You are on the third video of index properties, relationships and tests. In previous two parts of video, we have learned that phase diagrams and different technicalities of this chapter as well as fundamental definitions. I hope you remember all the equations and definitions of this chapter so that we can go further smoothly. Let us learn to derive relationships. So here we have to derive one relationship between bulk density and dry density with water content. So equation is like this: gamma D is equal to gamma B upon 1 plus W. We already know the water content formula, that is WW upon WD from previous video or fundamental definitions and equations. Now adding 1 on both the sides, we can get this. After doing some mathematical calculations, we can get this, and we can also write W plus 1 is equal to capital W upon WD, as capital W is equal to WD plus WW. Moving forward, here we can also write that WD is equal to capital W upon W plus 1. Now dividing both the sides of equations by volume V, we can write as WD by V is equal to capital W by V into small w plus 1. Small w shows water content and capital W is total weight, where capital V is total volume. Now WD by V can be written as gamma D, as it is dry unit weight, and W by V can be written as bulk unit weight. So gamma D is equal to gamma B upon 1 plus W. We have proven the formula. So this is how you can derive so many formulas for this chapter. Let us summarize some formulas. Summary of formulas. You must have seen all these formulas in previous video. Let us summarize that and then we will go to numericals. First formula, E is equal to VB upon Vs. N is equal to VB upon V. SR is equal to degree of saturation is equal to VW upon VB. AC is equal to VA upon VB. Same way, NA is equal to VA upon V. Furthermore, water content W is equal to WW upon WP. G specific gravity, that is WS upon WW. Gamma is equal to WS upon VS, that is unit weight. Gamma B, that is bulk unit weight. Total weight upon total volume. Same with dry unit weight, WD upon capital V. Gamma saturated, that is W saturated upon capital V, that is volume. Gamma submerged, W submerged upon total volume. Rho B is equal to M by V. Rho B is bulk density here. ID, density index, that is E maximum minus E upon E maximum minus E minimum. Here E maximum, that is maximum void ratio, E minimum, that is minimum void ratio, and E is natural void ratio. Let us move to some derived relationships like we have previously derived. Gamma D is equal to gamma B upon 1 plus W. Same way, gamma D is equal to G into gamma W upon 1 plus E. N is equal to E upon 1 plus E. Same way, E is equal to N upon 1 minus M, and E is equal to W into G upon SR. Furthermore, we can also write some derived relationships like this. Gamma B is equal to G plus E into SR into gamma W upon 1 plus E. Same way, gamma D for dry unit weight is equal to 1 minus NA into G into gamma W upon 1 plus W into G. Gamma saturated, that is G plus E into gamma W upon 1 plus E, and gamma submerged, that is gamma dash also, that can be written as G minus 1 into gamma W upon 1 plus E. So these are total formulas of this chapter. You should remember that so that you can learn numericals. Let us move to numericals now. Problem number 1. In this problem, porosity of a soil sample is given as 35%, and we need to find void ratio, dry density, submerged density, and saturated density. Take G is equal to 2.7. Let us solve this with all the formulas we have summarized in previous 2 minutes. So given data can be written as N porosity 0.35 and G specific gravity 2.7. Now finding out first item, that is void ratio. Void ratio has formula like E is equal to n upon 1 minus n. Now we know the value of porosity n. So putting the value of porosity n 0.35, we will get void ratio as 0.535. Moving forward to second item, dry density. For dry density, we have the formula that is gamma D, gamma dry is equal to G into gamma W upon 1 plus E. Here we do have value of G and E, and gamma W is by default 9.81 kilonewton per meter cube. So let us put all the values in this formula. G 2.7, gamma 9.81 and E as 0.535. Value getting of gamma D, that is 17.22 kilonewton per meter cube, and dry density, that is 1.76 gram per centimeter cube. Moving forward, saturated density. Now, whenever you are asked about saturated density, not saturated unit weight, whenever saturated density is asked, you have to give the answer in gram per centimeter cube. If it is asked that find out saturated unit weight, you have to find out kilonewton per meter cube. So let us move further. We have the formula of gamma saturated, that is G plus E into gamma W upon 1 plus E. Here G and E are known, gamma W is already known, so we are putting all the values of 2.7 G, E as 0.535 and gamma W as 9.81. I am getting the value as 2.105 gram per centimeter cube as saturated density. Let us move to submerged density. For submerged density, we have the formula that is gamma submerged, or we can say gamma dash is equal to G minus 1 into gamma W upon 1 plus E. We know the value of G, E and gamma W. Let us put this in the equation, and we are getting the answer as 10.84 kilonewton per meter cube or 1.10 gram per centimeter cube. Here I am asked about densities, so I am writing unit as gram per centimeter cube. If I am asked about unit weight, I will find out kilonewton per meter cube. Let us move to next problem. Problem 2. A sample of fully saturated soil. The soil is saturated here, has water content of 34%. So W small w, 34% is given. The specific gravity of soil is 2.7 and calculate void ratio, dry density and bulk density. Let us move to solution and write given data first. Given data, small w is 0.34, 34% is given. Here G is equal to 2.7 and SR is equal to 1 because of fully saturated soil. Let us move to solution, and first item is void ratio. We have the formula for void ratio is E is equal to W into G upon SR. We know the value of small w into G and SR is equal to 1 due to fully saturated soil. So putting all the values of W, G and SR, I am getting E void ratio as 0.918 and it is unitless. Let us move to second item, that is dry density. Here I will use dry density formula as gamma D is equal to G into gamma W upon 1 plus E. Here I have G and E now, and gamma W is by default 9.81, so I can find out the value of gamma D. Putting all the values in the equation, I am getting gamma D is equal to 13.81 kilonewton per meter cube. Here I am asked dry density, not dry unit weight, so I will find out it gram per centimeter cube, and the answer will be 1.4 gram per centimeter cube. Moving forward to third item, bulk density. Here I will use formula gamma B is equal to gamma D upon 1 plus W. Here in this formula I have gamma D now and water content now, so we can find out gamma B. I am making gamma B as a subject of the equation, so I can write gamma B is equal to gamma D into 1 plus W, and putting all the values gamma D and W, I can get gamma B as 18.5 kilonewton per meter cube. I am asked to find out bulk density, not unit weight. That is why I am putting 1.89 gram per centimeter cube. To convert from unit weight to density, we need to divide it by 9.81 units. Let us move to next problem. Problem 3. A soil specimen has a water content of 10%. Small w is given as 10%. and a unit weight of 20 kilonewton per meter cube is given. So unit weight is 20 kilonewton per meter cube. The specific gravity of the soil mass is 2.7. So capital G is given as 2.7. Determine dry unit weight, void ratio and degree of saturation. Let us write given data first, then we will go to solution of the problem. Here given data is small w water content is 10%, 0.1. Gamma B bulk unit weight is given as 20 kN per meter cube and capital G is given as 2.7. Now we need to find three things. First of all, let us find out dry unit weight. For dry unit weight, I will use the formula gamma D is equal to gamma B upon 1 plus W. Here I am having gamma B and W both. Putting all the values of gamma B and W. Gamma B as 20 and W as 0.1. Do remember that water content is always put in 0.1 and etc. format, not in percentages. Let us move further. Gamma D value comes up as 18.18 kilonewton per meter cube. Here I am asked about dry unit weight, so I will not convert it into gram per centimeter cube. Let us move to second thing, that is void ratio. For finding out void ratio, I will use the equation gamma D is equal to G into gamma W upon 1 plus E. Here I have gamma D now, I have G and gamma W value, so I can find out E value. So I am making E as a subject of the equation and putting G, gamma W and gamma D values in the equation. I will get E as 0.457. So I got the void ratio, and last thing is degree of saturation. For degree of saturation, I am going to use the formula E is equal to Wg upon Sr. Here I have E void ratio now. I was having W before and G before. Let us put all the values and find out Sr here. Sr is coming out as 0.5908. I can write it in percentages 59. I can write it in percentages 59.08 percentage. So that's it for this problem. Let us go to next problem, problem 4. This problem says that sample of sandy soil has 33% of porosity. Find density index if maximum and minimum dry unit weight of sample is respectively 18 kN per meter cube and 14 kN per meter cube. Take G is equal to 2.6. Here, basically, I am given gamma D max and gamma D minimum as 18 and 14 kN per meter cube. Let us write given data first and then go to solution. Here, I am given N is equal to 0.33 as 33% of porosity. G is equal to 2.6 and gamma D max 18 and gamma D minimum as 14. Let us solve the problem. We need to find three things here. First thing, that is void ratio. I will use void ratio formula as E is equal to N upon 1 minus N as I am having porosity. I am putting porosity value as 0.33. I will get void ratio as 0.492. Moving forward, I will need dry density, maximum and minimum to find out E minimum and E maximum. Here, if I am going to find ID, that is density index, so I need E max, E minimum and E. I got first item, that is E, but I need E maximum and E minimum too. For E maximum and minimum, I have to find out gamma D max and gamma D minimum formula. Let us find out E max and E minimum from there. Gamma D max formula is this, G into gamma W upon 1 plus E minimum. Here, equation suggests that if gamma D is maximum, dry density is maximum, then E will be minimum. So if the soil is very much dense, then its void ratio will be minimum. If soil is having lesser density, void ratio will be maximum. So we need to understand that logic for this problem. Let us move further. Here I am having gamma D max value, G and gamma W value. So I can find out E minimum. Let us find out that by putting all the values of G, gamma W and gamma D. Gamma D is given as 18 as max, G is 2.6 and gamma W 9.81. I will get E minimum as 0.417. For E maximum, we can use the same formula but with gamma D minimum, so E can be maximum. Same logic applies to this also. Here, putting all the values of G, gamma W and gamma D minimum, I will get E maximum as 0.82. Here, I am getting E minimum and maximum now. I am having E already, so I can go to density index as ID is equal to E max minus E upon E max minus E minimum. Here, I am putting E maximum, E minimum and E values, so I can get ID density index as 0.8148, or I can write in percentage 81.48 percentage. So here I conclude my session. In next session we will solve more numericals and we will learn this chapter more. Thank you.